Live. Hi, everyone. So welcome to the session with Ruslan and Bruno. I have to apologize to everyone because, as you know, there is a time difference change in Europe. And my assumption was that we're gearing towards North American time.
Oops.
Okay. I think she froze.
It's okay.
Nevertheless,
Yeah, so the problem was that it was time zone change in Europe, right? So it was the main.
yes, time zone change. Okay.
So yeah, it's a good point to to deliver second presentation for North America.
Absolutely, yeah, we can do that anytime. So anyway, I don't want to take away from the time. So yeah, Ruslan, if you want to take it away, please go ahead and share your screen. Bruno, let us know whenever you want to take over, or please let everyone know when is the good time to ask questions and so on.
Okay, cool. So everyone, Ruslan is going to start the presentation in a minute here. And while he does that, let me encourage you that's watching us here to ask as many questions as you want. I'm going to be monitoring the chat, and we want here to do a presentation that answer your questions. So feel free to go ahead. There's a chat on the side here or on the side here. Depends on what you're using. So take a look. Go there. Actually, you could start by saying hello and where are you from, right? I saw I saw a couple of people that I know here from the US, from Brazil. So how about you say where you're from, and then we can get started, right? So say in the chat. So hi Shiram from Chennai, India. Thanks a lot, man, for being here. That's great. So so you tell so now you tell you're from. We know who you are, and also you know where the chat is. So that's all great, right? Sankar from Chennai. That's great. Jonas from Qatar. That's good. Martin from Czech Republic. I love the Czech Republic. I don't know Qatar. I haven't been to Chennai, but I love the Czech Republic. Marcio from Brazil. Rodrigo from Rio. That's very good. Excellent. Andrea from Budapest. Excellent. From Belgium. Carlos from Belgium. So we have people from all over the world. That's great. That's great to have you all here. Wonderful.
It's awesome. Yeah, Java community is all around the world. It's very good to have people around the world. And thank you for joining this presentation. So Bruno, if you don't mind, I can start talking about the topic.
Yeah, go ahead.
Yeah, and today we are going to discuss very interesting and hot topic related to elasticity of JVM and Java EE application, now like Jakarta EE applications, running inside containers. So I will be fully transparent with you. This topic is new for me as well. Even I'm about 7 years in this area. However, it's updates are going on. So almost, let's say, every month we get something new that I learn as well. So, and the goal for this presentation to share things I already learned and collect additional questions so I can bring to people who develop the improvements. We can discuss together and maybe improve it even better. Good. So, and of course, it's as probably you understand, it's quite boring to talk to the screen like 45 minutes. So if you have questions, please feel free to ask them during my speech. It will be much more interesting for both sides. So, and today at the session, we will discuss the following points. What is the problem? What kind of problem we solve in general, right? And what kind of improvements were introduced recently in Java? And how these improvements work together with Jakarta EE? And we will go through some garbage collection testing. And actually, I'm sorry, I forgot to introduce myself. My name is Ruslan. I'm co-founder and CEO of Elasticity. platform as a service for ISVs, developers, and service providers. So we are working with Java Elasticity a long time, and specifically running containers more than 7 years. Even like containers became popular like last 4 or 5 years, but we had experience before. So great, let's jump to the problems. In the survey, which was collected in 2018, one of the major problem which was highlighted by developers around the world is large memory requirements. And it's true. Everyone knows that Java is greedy in terms of memory usage at start point and during runtime. So the question is like, can we solve this problem? And if we can, like, what are the possible solutions? Of course, there is a specific reason why Java consumes so much memory, because performance is important. And in the past, performance was always #1 for many applications. But however, is there any other options to, to maybe to give up for some performance but get better elasticity? So today, what we had in the past, you can see the screenshot from Visual VM, which is a tool that can analyze memory usage of JVM. And as you can see, there are 3 major points to consider. Like blue line, it's real used heap. So this is objects that are stored inside the heap. And then orange space is how much memory were committed by JVM. So how much memory JVM took from the OS. And then like max heap. So the red line, it's limit related to memory heap. We specify it through XMX parameter at the beginning. So, and what we have today, what we actually had in the past, that very often orange space get very high, but real usage is less than the max heap, let's say, right? But JVM keeps unused RAM and it does not release back to operation system. In the past, when we run JVMs on top of bare metal or inside like virtual machines, and when we run like multiple applications inside one JVM, the problem was not so big and people did not pay attention. But today, we are living in another world. So we run many JVMs, specifically in microservice world, right? And we can run like thousands of JVM inside one big bare metal machine. But if all the 1,000 JVMs are inefficient, so we lose a lot of money and infrastructure becomes underutilized. So it's not really good. Let's discuss the reason why we seek for JVM elasticity. I will mention specific cases. I believe people will come up with additional cases, but these cases are obvious, at least for some group of people who are working on the solution. So #1, let's say like cron jobs for data processing. Very often we have cron jobs that can become active at a specific period of time, and they can pull a lot of data inside the memory, do some kind of aggregation or segregation, and then like store new data in the database. And then they go to sleep mode again. Very often after such kind of processing, as JVM does not release RAM back to operational system, so we have committed but unused RAM inside the JVM machines. So this is one case. I hope it's clear. If not, please ask the question. Second case, when, for example, you run like 100 or like, let's say like 1,000 of JVMs inside one big bare metal machine or like large virtual machine. And for example, at some point, one virtual machine needs more JVM needs more resources. So you can give these resources from the common pool for like temporary burst, for temporary data processing, or for temporary load spike. And then when load spike goes out, you can release these resources back into the pool. So another JVM can get it when it's needed. And another example, some service providers introduce a pay-per-use model. It means you pay not for the limits of your virtual machine or your bare metal. You pay for exactly amount resources your applications consumed. So if your application is efficient, I mean, like it can release unused RAM back to operation system when it's not needed, you will pay less at the end. So it saves money for you, and you can reinvest this money in the product development or just increase salaries to a team. So by decreasing money spending on the infrastructure. So with Elasticity, it's possible to adjust resource usage on the fly. Without Elasticity, it's impossible. So you have to do a restart of JVM, which leads to downtimes. And very often, downtimes are not acceptable. Or it leads just to out-of-memory error or to out-of-memory kill exception. So your JVM will just die. This is the reason why we are trying to bring Elasticity to JVM, to Java world. Let's talk a little bit about some problems when we face. So specifically, what is out-of-memory error and what is OM killer? So there are many kind of out-of-memory errors. They happen in different spaces, and a good explanation will be this picture. So we have like different layers, like operation system where it's like shared libraries are located. Then we have like heap with young and old generation, and then we have off heap space where like direct byte buffer and code cache are located. So if you're today we are talking specifically about heap. Of course, problem exists also inside of heap, but it's not for this session, because again, like we did not get to that point. We are working now only on improving elasticity of the heap. So, and when out-of-memory exception happens, when blue line cross the red line, so when the real used resources gets very close to XMX parameter, to the limits of JVM. And another possible exception when native off heap, let's say RAM gets close to the container's limit. So in this case, out of OM killer will happen. So operation system will kill your JVM process and you will lose all your state. In this case, out-of-memory exception will happen. So your JVM will stay, but it will be an error inside your application. So you will need to handle this somehow. So looks like too many points to consider, right? It's true, there are too many points to consider. However, we believe step by step, we can clarify all these points, and many people will understand better how elasticity works with JVM. In addition to all the mentioned points, I would like to add, it's very important where is your JVM running, because there are different kind of containers now on the market and different kind of virtual environments. So you can run inside Docker, or you can run inside, let's say, LXC container, or inside Virtuoso containers, or inside virtual machine, bare metal. So because some container technologies do not provide enough isolation, let's say, so they expose limits of the host machine, and it can be a problem for you. So you need to consider runtime virtual environment. So now let's talk a little bit about pay-per-use billing model. Just again, like to clarify why it's important. For example, today, very often infrastructure service providers sell virtual machines, and you go buy like, let's say 16 GB of RAM, and you always pay for these limits, while your application can use much less. So new kind of billing model, new generation, let's say, billing model, which is called like pay-per-use, offers a more efficient solution. So you can set the limits, but you will pay only for what you use. And if we can make Java elastic, so we can save again like a lot of money. Good. So we decided to start improving vertical scaling of Java from Heap, but there is also ongoing work related to XMX parameter when you will be able to adjust this parameter on the fly. For example, when it can be helpful, for example, you did a wrong assumption at the beginning, right? You said like, okay, my JVM needs like 32 GB of RAM, but in reality, like your JVM needs more, like let's say like 4 more GB of RAM. So today you have to restart the whole JVM, and again, like you will lose the state, and JVM will again like read all the state from the disk. It will increase IO performance will degrade, so it will slow down everything. If we bring more elastic solution to enable people just to adjust XMX on the fly, it will help to solve this problem. And there is ongoing work on this. However, as I mentioned today, we will focus only on elasticity of Heap, how to bring this orange committed RAM down, how to release unused memory. So in the past, we did some workaround because it was possible to do with specific approach when you explicitly call a full garbage collection cycle. It's not very good approach because it significantly influences performance. So your application can degrade, performance of application can degrade. However, it was only one possible solution. So, and it looked like this. When orange line grows up to max heap, blue line grows, let's say like till the middle, right? And then load goes down, and you call like full garbage collection cycle, and orange line goes down as well. It was possible to do with specific garbage collectors, not with everyone. For example, G1 was suitable for this kind of approach. So we did a lot of tests, and we tested on real applications. We presented the solution to end customers, and we ran productions on top of it. And we figured out, okay, it can be a workable solution. So many people are satisfied with this. And we decided, okay, maybe we need to introduce some patch inside JVM. And that's what we did, by the way. We introduced 3 parameters that can configure elasticity of JVM, specifically if JVM is running with G1 garbage collector. So you can follow this link. This improvement was added to Java 12. So it's available now. You can enjoy this improvement. And in general, it works like this. So now it looks very elastic. So as soon as used heap is not, as soon as memory is not needed anymore, JVM memory usage goes down automatically. You don't need to call like full garbage collection cycle. So you can easily configure it now. And again, like this is the parameters that you need to take into account while configuring elasticity for G1. And community understood, let's say, the importance of this improvement, and we got recognition from the community. Specifically, want to highlight contribution of Rodrigo Bruno, who created the patch, let's say, who created the specific code for this patch and contributed it to the open source OpenJDK. Good. Let's go a little bit now to real results, real tests. So there are many different kinds of garbage collectors. We will run a set of tests with different garbage collectors to see how they behave. And we will run a simple test. So we will just create array with string array and add it to the linked list and do it in cycle. So first of all, we will test G1 garbage collector. By the way, any questions so far? Bruno, do you hear me, guys?
Yes, Ruslan, we hear you. There's no question so far. It's all fine.
Okay, good. So anything happen, just let me know. So G1 garbage collector. How it works? You need to specify, for example, plus use G1 GC, and you specify a periodical interval when you need to call garbage collection cycle. So at this example, every second I specify like please call garbage collection cycle every second. So and JVM will take it will analyze, and if it's possible to do release without full garbage collection cycle, it will do. If not, then it will call full garbage collection cycle. So as you can see, it's quite elastic now, right? In the past, it was not like this, but now it's elastic and it's fully automated. There is additional threshold. For example, if your system is busy and you don't want to call garbage collection cycle because like you don't want to do like to face like performance degradation, you can specify like specific threshold which is related to load average, and say like, okay, if load average is more than, let's say, like 1 or like 0.5, please don't do any garbage collections. So please don't do elasticity. But if it's less than the threshold, then JVM will do the job. It's very useful again, like for productions even, right? Like or for highly loaded stage environments. So you can regulate performance and elasticity. There is an issue. There is one important issue to take into account when you do it inside Docker containers, because still today Docker containers, they expose limits of the host machine inside. So JVM does not recognize like load average inside container, but it's quite easy to solve. You need to do mount of LXCFS, and there is a specific example how to do this. You can go and read articles how it works. But if you do it, then the problem will disappear. So then you can check load average right inside the container. So just important point to mention here. Another one good garbage collector that becomes more widely adopted, which is called Shenandoah. This garbage collector, I like this garbage collector, by the way. It's very elastic. It has different kind of options. It can run large heap. It can be elastic. So, of course, it's still new compared to other garbage collectors. But as I know, people are committing a lot of efforts to make it like fully production ready. And I like it very much because it has specific option, heuristic option like compact. And when you specify it, then your JVM will be very much elastic. So you can use it for, again, like for your needs, to take a look how it works, and maybe to, you know, like to promote it to productions if it does not influence your performance. So compared to G1, I would say it's more efficient in terms of CPU usage and even like maximum usage during the spike loads. Of course, again, like it's a synthetic test. It cannot reflect all cases. So I just must to to emphasize this, because like there are some cases when like G1 outperforms Shenandoah. So, but at my case, at my specific test, it's different. So another one garbage collector, which is quite new and was developed by Oracle for large heaps, ZGC. And recently in JDK 13, Oracle team introduced same solution, like uncommit unused RAM back to operation system. So as you can see, it's going on. People are improving garbage collectors and taking elasticity into consideration. So there is an example how it works on the same test, right? There are options you need to specify, like unlock experimental VM options, then use ZGC, then uncommit delay and collection interval. Like so, you can go after the presentation to the website of this garbage collector and check specific detail of these options. But they enable, in short, again, like they enable elasticity. And as you can see, our JVM can get memory and release it back dynamically. Next one is C4 garbage collector from Azul Systems. It's a commercial solution. And I believe, again, like Zinc and C4 was one of the first solutions that provided elasticity for Java on the market. And recently we got access to the solution and tested how it works. It's very interesting one. You just specify like use ZST, but you need to set up it properly. So there is a specific approach how you must set up. Sorry. So there is a specific approach how you must set up Zinc JVM. I believe if you reach Azul Systems, they will help you. But in general, we did testing and it's elastic. So as you can see, elasticity is quite good. You need to, but to measure it inside containers, you need to enable C groups inside configuration files. So I will not go to so deep details. If you have additional specific questions about one of the garbage collectors, feel free to follow up me after this conversation. So another one, concurrent mark sweep garbage collector. Actually, it's going to be deprecated, but still just good to understand how it works. It can be elastic as well, but you must force full garbage collection cycle. So explicitly inside your code or outside through GKMD, I would say. And even you need to do it like 4 times to bring it really down to the 0. Okay, next one is a serial garbage collector, similar to concurrent mark sweep. So you must explicitly call full garbage collection cycle. Good. Next one is OpenJ9, which was initially developed by IBM and now is under Eclipse Foundation. This JVM introduced elasticity earlier than, let's say, some other garbage collectors. However, I am personally facing some issues to configure it properly, to measure real usage. So in my case, JVM just consumes RAM, like, and keeps it, and I cannot measure like how much resources was used in reality. I reached developers and they provided some specific script how to measure real usage. So yes, after I did it, I figured out, okay, like there is some elasticity and memory goes up and down, but still, like my metrics inside container, they show me that memory is flat, and this is not something convenient. Again, like I don't want to blame OpenJ9 developer. Most likely it's related to my configuration, so I didn't configure it properly. At the moment, I'm talking to developers, and as soon as I get clarification of this point, I will share these details with the community. And just just for comparison, epsilon is not elastic at all. Like, so if you want to do elasticity, epsilon is not for you. Parallel garbage collector is not elastic at all as well. Like, so it will get the RAM from operation system and it will keep it forever. So it will not release it back. So guys, as a quick summary, as you can see, there are different garbage collectors and they can work in different way. And moreover, you need to take into account some specific major points of the elasticity. So I created simple illustration for this. Like, so A, what is the initial memory usage when JVM starts? B, what is the maximum usage for your load? What is the maximum usage at the largest, let's say, load spike? C, what is the growth speed? So how fast JVM can get from A to B? Because like what I saw, some garbage collectors can be faster compared to others. So, and it directly influences the performance of your application. So you need to take into account. D, like how long JVM keeps unused RAM. So let's say like after the load goes. So because some, again, like depending on the options and the parameters, it can stay longer or shorter. And it depends on your load. Again, like if you have dynamic load and it goes through a short period of time, maybe you don't need to do this elasticity. But if you have enough time, like to bring it down, like, and, like couple hours without load, it can save you some resources. So you can utilize by other infrastructure. So then, E. Release speed, like how fast it release. So does it go really fast, or like you need to do like several steps to release full unused memory? And F, what is the minimum usage after the release? Because like very often it happens that after release, memory is still higher compared to initial size. So take into account these all points, play around, test it, and provide feedback. And maybe again, like all together, we can make it more convenient and more automated. So I did the same testing in Kubernetes. During the lack of time, I will not go.
So Ruslan,
yes.
Yeah, before I go into Kubernetes, there's a question here from Sergi, and he asks about if there's any negative performance effect. So can you talk a little bit about the different garbage collections and their performance effects?
Yeah, definitely. So very good question. Guys, like if your main aim is performance, just don't do elasticity. Just get everything, all RAM inside, like, and keep it. Because like, again, like allocating memory is very heavy task. So it's CPU, it consumes CPU, and it takes time to get it. So if your, for example, applications is really critical, like to performance, just don't do it. Like, so just specify like XMX equal like to XMS, get all RAM from the beginning and run it like this. Then like second option, like, okay, like if performance is important, but it's not critical for you, right? So for example, because like, let's say like you can wait like 100 milliseconds, like, right? Like, or 200 milliseconds, while like additional 200 milliseconds, right? So for like web applications, in many cases, it's not so much critical. And very often, again, like web applications, they have dynamic load, like because people, come to the store like in the morning, and when they sleep, application does nothing. So for such kind of applications, again, like if you properly configure vertical scaling, it should not influence your performance. because like you can again like measure, okay, there is a big load inside JVM. Don't do elasticity. Okay, there is no load inside JVM. Like just bring it down. So it's possible to do to find an optimal combination for web applications, let's say. And then
and Ruslan, this optimal combination, is this based on the exact way your application works, or like a web application has a similar usage? How do you do this? Sergi asked if there's a best practice for those parameters, and Gordon goes further. If there is a tool or a test that you can measure which configuration works best for you, is there anything like this?
Yeah. So very good. Sorry. Very good. So optimal configuration, it depends on several layers, to be honest. It depends on several layers. First of all, like what kind of garbage collector you use? One. Then like how do you configure this garbage collector? Like, because different garbage collector provide different options, right? Like, and you can fine tune them for specific workload. Then it goes like, okay, like how your application works and what is the load. For now, I will suggest you to take a look, let's say like weekly load, like, or like daily load, right? Like, so you take a look at your daily load, figure out, okay, like this is a like maximum, right? And this is a minimum. And this is the speed of the growth. Like, so people are coming to the website during 1 hour, let's say, like, right? Like, or during like 2 hours. Like, so the load grows like during 2 hours. Like, so, or like load goes like during like 10 seconds. So it very much depends, like, because like 10 seconds and 2 hours it's a huge difference. Yep. So take a look at your current load, analyze it, and then you will be able to get a better understanding, like what exactly you need, like how to tune it. There is no like secret bullet for everything, to be honest. Like, I hope and I believe, and again, this is additional reason why we are doing this. In the future, we will introduce something like adaptive performance optimization. So when application runs and checks, like, okay, like I have this load, like, and it's better to tune these parameters for myself, like, and when like load spike comes, like, and load changes, JVM will be able to adjust parameters inside, like, like keep RAM longer or like release it faster. So, but it's for the future. Like, for now, we need to solve like this simple vertical scaling, like, because really, like, we were struggling with this issue like for many years. Like, all other languages are elastic, like, but Java is not. Like, it's not fair. It's not sexy. Like, so we want to make it elastic. Good. Anything else to add to this question?
No, I think that's fine. There's some other questions. I'm waiting you to finish just for the other questions.
Okay, no problem. So guys, like, just to mention, I did the same in Kubernetes, and there is a link to Kubernetes YAML, so you can go like and see what is inside, like how it works. Maybe you can run inside your Kubernetes, and there is Prometheus and Grafana already. I mean, like, YAML for Prometheus and Grafana, so you will be able to see graphics like this, let's say, right? So this is G1 in Kubernetes. This is Shenandoah in Kubernetes. ZGC in Kubernetes, right? Like, so, and I have like all of them all together. So take a look at this. It's very useful, to compare like how all of them are working. Like, and as you can see, there is a difference. Like, first of all, based on the maximum like RAM consumed by JVM. Then like how fast JVM does the same job. Like, for example, at this specific case, like, again, like ZGC did longer compared to others, but like, because I configured this in a specific way, like, I reached developers, they suggested me to improve some parameters, like, and it will be the same. So at the next presentation, I will show like, okay, like, this is if I run like ZGC with different parameters, like how it works, like how it influences elasticity. So just to, again, like to mention that there is a specific package for Kubernetes, and you can play with this package. Then coming to finally to Jakarta.
And
Yeah,
Ruslan, since you're just gonna skim it through, is this presentation available so people are gonna receive a link about that?
Yeah, Tatiana will share the link after. Yeah, we will share the link in Twitter. So please follow our Twitter. Yeah, and Jakarta will share the link as well.
Okay.
Good. So next one, we need to understand like where the memory can be consumed, right? Like, so now we solved, let's say, like partially solved like elasticity inside JVM, right? But like take a look, of course, like inside application server, like then like libraries you bring with your application, and inside your code, like your code should not have memory leaks, and it should release unused objects timely. Like otherwise, like elasticity will not work. Like, so like please take this into account. Like, so now JVM is elastic. Next is your responsibility. So application server, libraries, and application. So, and if you make all of them elastic, at the end, memory usage will be elastic. So we did simple load testing with Payara, which is great solution, and it's Jakarta EE certified. So the test is quite simple. We created GSP page where we just put object inside the session. So we put like string object inside the session, and then sorry, and then we call the link like this page in loop. So, and how it works? Look, this is Shenandoah. You see, it's elastic. So now it's elastic. In the past, it could keep the RAM like this maximum RAM like for a long time. Like, so you don't need it, but it's still there. So now it's elastic. And second one, G1 with Dragonwell. I forgot to mention another kind of garbage collector, which was developed by Alibaba, and Alibaba recently introduced these improvements to the community. So they shared their work, and this is ongoing conversation, like how we can utilize this work and how we can commit this into OpenJDK. Right now is, let's say, like analysis phase. We're testing the solution, but good point is designed for G1, and it's it can work with Java 8 as well. So because like there is some kind of issue with Jakarta and the new Java releases, because Jakarta, I believe, officially supports only Java 11. So we cannot use all this beauty, improvements from the recent releases in Java 12 and Java 13. But like there is a solution for now. Go with Shenandoah or Dragonwell, or just G1 and do periodical explicit full garbage collection cycles. Good. So that's in short about heap usage. Now let me tell a little bit about the future. Like, so what we want to do, like, and where we are moving. As a community. But now the next step is heap resizing, like how to resize this XMX parameter on the fly without the need to restart JVM. It's not easy, to be honest. Like, so it's really hard for, let's say, like for G1, like to do it from scratch. But like to do it, we need to rewrite garbage collector from scratch. But there is a possible workaround when we just commit much more RAM in advance and then specify, okay, this is a new soft limit. So something similar was introduced inside ZGC garbage collector. So the parameter is called like soft max heap size. So for example, how it works, you specify like XMX, let's say like 64 gigabyte, right? and then you say like, okay, like soft max heap size is like 32 GB, and JVM will try to keep used RAM under 32 GB of RAM. So it will try to, like to call garbage collection cycle as more time as RAM usage comes close to this limit. However, if JVM just cannot live without extra allocation beyond this limit, soft max heap size, then a ZGC implementation, ZGC will allow you to go higher soft max heap size. So it will give you from this extra pool you have. This is the reason why it's called like soft. So again, like just to summarize, JVM will try to keep RAM usage below soft max heap size, but if it's like mandatory, then JVM will give it higher. Will allow memory go higher this limit. Good. We are working on the same similar, let's say, solution for G1. The idea a little bit different. Like we want to introduce like hard limit, because like we think and we believe we must have a hard limit as well if JVM goes higher. Yeah, because what is possible, like it's crazy, but it can be done. Like, so you can set XMX higher than container max limit. So because you can resize containers limits on the fly without restart of the container now. So later you can go like, you can resize it. But you cannot resize XMX. So you can resize only softmax heap size, right? So, and the idea is play with all these parameters, right? Like, so you set XMX higher than container max limit, and then you specify new max limit, like softmax heap size. And then your JVM will work inside this space here. So, but if it's needed, then you can, if more RAM is needed, then you can increase container max limit on the fly and increase the soft max heap size or hard max heap size on the fly, and and enjoy elasticity, adjusting maximum limit on the fly without downtime. Something similar was introduced and implemented in OpenJ9. You can adjust max heap size through memory MX bin. Actually, it will be good to get some feedback from people who did it, who play it with the solution. But again, as you can see, community is moving into this direction. And the most advanced, of course, like was Zinc JVM from Azul Systems, because they created many years ago. I'm not sure, but not many people. I'm not sure why, but not many people knew about this. And they have very unique solution. It's fine. You can tune it in a different way. So then when actually, in a good point, for example, you don't need to change the source code and configurations of your JVM. For example, if you just bring as is, and it's so smart, it will not throw out of memory error or like OM kill. It will just give you extra RAM from common pool. So there is really like unique magic behind it. Like it's out of scope of this presentation, but like it's possible to do now with C4 garbage collector at Zinc JVM. So just for your understanding, like you can follow up after the conversation, and if you are interested, I can provide specific details how to configure it. So guys, this is in short. I hope it was clear. There are a lot of material. Yeah.
We've got some questions here, then, man.
Yeah, go ahead.
There's a question from from Zablon that he talked about. Is elasticity based on memory only? Can you also have? I know you're talking about only memory here, but can you talk a little bit more about elasticity on processors, disk, and other things?
Oh, very good. So, look, elasticity for processor, it's available by default now. Yeah, it's available by default. There are no problems. So your JVM will not be killed if it requests more CPU than is available. So of course, you might have increased load average inside the operational system, but it's not very critical, let's say, right? So that's the reason, actually, we want to make memory as elastic as CPU to, like, to get rid of this out-of-memory errors. Yeah, that's one point. Then, like, talking now about disk space and network, they can be elastic as well. So today it depends on the service provider. Like if you go to, let's say, to like large service providers who offer virtual machines, you always pay for the limits for like how much you expect to consume at the maximum point. We believe it's not fair, like, right? Like, so this is the reason why we promote very much, let's say, elasticity, pay as you use. So, for example, at this graphic, you have like CPU, memory, network, and disk space, right? Like you can see like limits. They're much bigger than real usage. Like, why should people pay like for what they don't use? Like, so many service providers, they just oversell it to other customers. Like, it's not fair. Like, so it's better to come up with a smart idea, like, how to rebalance load inside the cluster, like, and offer pay-per-use model. And big vendors, actually, they started to adopt this model now at serverless solutions. They offer pay-per-use model. So to summarize, like,
So Ruslan, you're talking about elasticity in terms of memory and pay per use. Can you tell a little bit? That's one of the first questions we got here from. Oh man, let me get here. First question I got here from Vladi, and Vladi was a little bit confused in the beginning because you're talking about elasticity and we're talking about Jelastic here, and you didn't talk about Jelastic at all so far, right? So the whole discussion was about Java and elasticity on Java, but can you tell us a little bit how Jelastic itself is using the elasticity of Java and what Jelastic is?
Okay, so because look, like it was not about Jelastic session, it was about Jakarta and elasticity and so on. Yeah, but if people are interested, definitely I can tell about Jelastic. So Jelastic, first of all, it's acronym Java Elastic, right? Like, so let's say like 7 years ago, like again, like I was simple developer, like, and I faced the same problems. Like I was unhappy with so greedy Java, like, and decided, okay, like maybe we can solve this problem somehow. Then I discovered, okay, there are containers on the market and they are elastic, and like PHP is elastic and another kind of solutions are elastic, but Java is not elastic. So maybe we can solve this problem. So this is the reason why we started to, like to put efforts behind this movement. And I started to talk to different people around, to people who are working on garbage collectors, like to get their opinion, like what they think about this. And honestly, at 2011, I heard negative feedback, like, people don't need it. Like, so, because like, performance is #1 now, like, so people are fine to run as is. However, later when containers came, like, and became more popular, like when more visual environments became more popular, like, so the problem became more serious and more people started to pay attention to this. Like, so, and fortunately, other people that develop different solutions, started to contribute to like OpenJDK, and they started to design new garbage collectors, keeping in mind elasticity from the beginning. So again, like talking about Jelastic, like Jelastic, it's a platform as a service which was focused on Java elasticity from the beginning, let's say. However, it's a platform service for all languages. We are not religious about languages. We love, like all languages, because it's matter of your business goals. Like, so you can do some job faster with PHP and some job better with Java. Like, again, like it depends on your task, like what kind of skills you have, like let's say talents are available on your market, like, and so on and so on. So Jelastic, it's a elastic platform as a service for developers. We again introduced Elasticity for Java, and we introduced it pay-per-use models. I would say that's the two major contribution to the community. Yeah, but in general, again, like another good point, like as a company, we are a software company, so we don't own data centers at all. Like, so Jelastic, it's like a cloud solution. There are many service providers around the world. Like, we offer, we evangelize freedom of choice. Like, so you can go and check service providers in Europe, for example, right? Like, and like in Latin America, and like in multi-region, for example, right? And if you don't like one of them, like, you can easily migrate to another one. So it should not be locked in. You should not be locked into one specific provider, right? Yep. And actually, I believe we should have competition, like, because like if only like 3 big major players grab like the whole market, like, right, like, and maybe it's not good for the whole community. Like, so I believe we should like have more options on the market. That's in short about Jelastic.
Okay, that's great. So there's some more questions here.
Yep.
So Vlad says, so to sum up, if there is a performance footprint, what would be the best use case to consider when enabling elasticity on JVM? So basically, I mean, do you need to do anything as a developer? Do we need to do anything specifically, or if we just use Java 12, that's enough? Very
good question. I like it very much because it depends on your source code. If you write good source code, I mean, it releases memory, so you have no memory leaks. Then you just use Java 12, and it's enough. So you will need to learn a little bit, like, okay, like how to fine tune it. But this is the reason why I'm here. So I want to help you to understand like how it works, like, and maybe to get your feedback, like, about inconvenience. So then I can bring it back to people, like, and we can do some additional automation around it. So, but in general, if you write a good code, so it will be enabled by default, like so. And I saw in many cases when customers just come to us and they say like, like we faced even like out of memory errors, like we said, like, okay, just enable this option, and out of memory just disappeared. Like, so I don't know. It can help you even without code change.
Okay, all right. So Zablon asks, he saw some graphics on the slides. Can we add a monitoring hook to send alerts in case of reaching out those limits?
Reaching out the limits is you mean like XMX limit or which one? So
he didn't say specifically which limits, but there's a lot of limits that you are in
right.
different slides.
Right. So let me show. Yeah, here, right. For example, so if you reach like XMX, application will throw like out of memory error. Like then you can sign up. There is a specific option out of memory error. Let me try to find it. On error. It should be like this. I don't remember exactly, but yeah, like you can specify some specific option on out. It should be like this. Sorry, out of. Yes. Yeah. So yeah, you can subscribe on this event. Then you can do something like send mail to sysadmin, like, guys, like take a look, there is an exception. But I believe the rest, like, you need to analyze the logs, so you can enable logs and check garbage collection cycles, or you need to write like XMX bin to check what is going on inside, or just just to check it from your application, because you can analyze the real usage directly from your application.
Okay.
Yeah, right. There is by the way, if you go to the link, there is an example, there is a source code of this vertical scaling test. So, and there is an example how I check memory usage. Yeah. So you add memory MX bin, and then you get like heap memory, like used memory, committed memory, max memory. So you can use it inside your application and like specify some triggers.
Okay. All right. So there's lots of people there saying thanks, Ruslan. Thanks, Ruslan. Didn't know there was so much to learn about garbage collection. I've been ignited with lots of new ideas. There was Edwin. And VS says, thanks, Ruslan. Vladi says, thanks, was good intro to Elasticity JVM. Sergi has asked if there is any way to clear unused meta space.
Very good question. I don't know, to be honest. Like, I cannot answer you now. So,
all right.
Yeah, like I will take this question. I will do some homework. Like, so, but like I believe it should be elastic by default. So it should be elastic by default. Like, so, but it's really like next topic to talk about. Like, so let's fix at the beginning heap, because like the majority of problems are inside the heap.
Okay. All right. So guys, so everyone, Tatiana puts some of the links there on the chat, right? So you can get more information. There's a little video that can talk more about this. There's also Twitter from Jelastic, and as soon as we finish here, we're gonna go on the Twitter right there, twitter.com/Jelastic. We're gonna go there and we're gonna share the presentation. We're gonna share the recording of this presentation and also the link for the slides. So just follow Jelastic right now. You're gonna get it. Okay.
Thank you guys for joining, and thank you for the questions. If you come up with additional questions, feel free to follow up through social media so we can discuss.
Right, and also there is a lot of different tech talks. So thanks for the Eclipse Foundation for hosting us here. They do a lot of webcasts like this, so you should follow the Eclipse Foundation to be notified of the next presentations. And there's actually a link right there on the chat with the recording from this presentation here. So you just copy that so you don't miss it later.
Okay, thank you guys. I'm going to end the broadcast now.
Thank you. Bye-bye.
Okay, thank you.